Next, let's try to locate the centroid of the given beam cross-section with respect to the x-axis. So let us try to divide this into two areas. So we have two rectangular area. So this is a composite figure because it consists of more than one spatial geometric figures. So in this case, let us consider that this is your area 1 and this one in here is your area 2. Hence, this is therefore equal to. So with respect to the x-axis, so let us try to draw now the x-axis. And we now have the first area. This is your first area. So we have first area. So we have now the first area. So this one is equal to, this is 40 millimeter. And the distance from this point up from the x-axis to the bottom of the first area is equal to 100 millimeter. It's your 40, and this one is equal to 100 millimeter. Now the centroid is now located at this. Of course, if you try to refer to the centroid of some common geometric figures for a rectangular area, it is equal to 1/2 of the height from the base, or it is 1/2 of the base from this axis in here. Since we are required to determine the centroid with respect to the x-axis, so this is now the centroid of the first area, such that 1/2 of its height is 20 millimeter. And this is therefore your y1. So we now have your y1. So that your area 1 is now equal to, so this one is 200 millimeter. So we have 200, multiply this one by 40. So that is now your area 1. And this is therefore equal to 8,000 square millimeter. And your y1 is now equal to 1/2 of 40 is 20 plus 100, and therefore it is equal to 120 millimeter. Now, plus the second area. So our second area is this area in here. So this is now our second area. So from the x-axis, so we have the second area. So this is your area 2. So again, this is equal to 100 millimeter, and this is equal to 20 mm. So that is 20 mm. So we have 20 mm. Again, this is a rectangular area. Hence, the centroid from the base of this area is 1/2 of its height. So if that is 1/2 of its height, so it is located somewhere else. It is located at that point. So this is now your y sub 2. A y sub 2. So that is now the second area. So that your area 2 is equal to 20. Multiply this one by 100. Or this is equal to, we have 2,000 square millimeter. And your y2 is now equal to 1/2 of the height. Hence, that is equal to 50 millimeter. So that, let us try to determine now your area bar y. So your area bar y is equal to summation a multiply this one by y. So let us try to tabulate this one in here. So we have now tabulate now the area. So this is therefore your area 1. So we have the area, so this is your area 1, that is your area 2, and we now have the summation. So that the area is equal to, for the first area, we have the area in here in square millimeter. This one is 8,000 and the other one is 2,000. Next, we now have your y. So for the first area, this is 120 millimeter. And for the second area, it is equal to 50 millimeter. So let us try to get now your AY. So that this is now your AY. So 8,000 by 120, that is equal to 960,000. And 2,000 by 50 is 100,000. Summation of A, which is now your capital A or the total area, so it is equal to 10,000 square millimeter. Summation AY is equal to 1060, then we have 0, 0, 0. Now, so that if you will now going to get your area bar y is equal to summation AY. So your bar y is now equal to summation AY all over the total area. And this is therefore equal to summation AY is 10, 6, 0, 1, 2, 3 all over the total area, which is equal to 10,000 square millimeter. Hence, your bar y is equal to 106 millimeter from the x-axis. So if you try to take a look, so this is 100. So the centroid of this figure is located at that point. Hence, this is therefore your bar y. So your bar y in here is now equal to, so your bar y is now equal to 106 millimeter. Okay, so let us try to locate the centroid of the given figure shown. So the centroid is located at a distance d from the x-axis. Again, let us try to divide this one into spatial or common geometric figures. So again, we have three rectangular geometric figures. So I'm going to consider this one in here as area 1. And then I'm going to consider this as area 2. And this is now your area 3. So your area 1 is 1. And this is now your 6 inches. So this is also 1. And this is now your 6 inches. So we have 6 inches. And we have 1 inch. So again, the centroid of the first area with respect to the x-axis is 1/2 of its height. So I'm going to consider this one as y1. This is your y1. And then similarly, the centroid of the second area is 1/2 of its height. And I'm going to consider that one as y2. So this is y2. And the third area, the centroid is 1/2 of its height. And this is therefore equal to 0.5. So that is now 1/2 of its height. And I'm going to consider this one in here as your y3. So we now have the first area. So your area 1 is equal to 1. Multiply this one by 6. And this is equal to 6 square inches. So your y1 is now equal to 3 inches. We have your area 2 is equal to 1 multiply this one by 6. So that is 6 square inches. And your y sub 2 is equal to 3 inches. Now similar, your area 3 is equal to 6. Multiply this one by 1, or that is equal to 6 square inches. And your y sub 3 is 1/2 of its height, or that is equal to 0.5 inch. Now, let us try to tabulate now the results. You try to tabulate now the results. So we have area 1. So we now have your area 2. We have your area 2. And this is now your area 3. And this is now the summation. So we now have your A1. So this is your area 1. This is your area 2. That is your area 3. And we now have the summation. So their corresponding area in square inches are, we have 6 square inches. This one is 6 square inches. And the other one is 6 square inches. And we now have your y from the x-axis, the centroid of the spatial geometric figures from the x-axis, which is now your y. And this is equal to 3. We have 3, and this one is 0.5. So let us try to determine now your area times y. So your A, multiply this one by y. So we have 6 by 3, so that is 18. We have 6 by 3, that is also equal to 18. And 6 by 0.5, it is equal to 3. So summation area is equal to 18, and summation AY is equal to 39. Hence, we are now ready to determine your centroid D. D from the x-axis. So the total area, multiply this one by D, is equal to the summation AY, and therefore your D is equal to summation AY all over the total area. Hence, the value of D is now equal to, the value of D is now equal to 39 all over the total area, which is equal to 18. And therefore, this is therefore equal to 2.167 inches. So that is therefore the location of the centroid of this given figure from the x-axis. Let us try to locate the centroid of this given plate area shown. Now, so I will going to consider, so there is a hole at this portion. The radius of this hole is equal to 4 inches. So I will going to get the whole rectangular area as area 1. And I will going to get the circular area or your hole as area 2. Now, such that the whole area minus the area of this circular section is now equal to the net area of this one. So, we have your area 1 is equal to, so that is 14 by 20. So that is 14 multiply this one by 20, or this is equal to 280 square inches. So this is 280 square inches. So the centroid of this area is located 1/2 of each height and 1/2 of each base. So this is now your x of 1. So your x of 1 is equal to, so we have your x of 1, and this one is now your y of 1. So we have your y1. So that your x of 1 is now equal to 7 inches, and your y sub 1 is equal to 10 inches. Now, let us try to subtract the area of the circular portion or of the whole of that plate, so that your area 2, area of the circle, is pi r squared. So that is now your pi r squared. And this is equal to pi, and the radius of the circular area is 4, and that one is square. And this is equal to 50.266 square inches. You try to take note that we removed the area, and therefore this is negative. So area removed is negative. Now, let us try to consider or get now the centroid of this area. For the circle, of course, it is at the center of the circle. So this is now your x sub 2. So we have your x sub 2. And we now have your y sub 2. so that your x sub 2 is equal to so this is equal to 6 inches. And then your y sub 2 is now equal to, or that is equal to 12 inches. So that is therefore the centroid of the two corresponding areas in here. Again, let us try to tabulate now the values of this one, or the result. So we have, so this is now area. So we have area 1. And then we now have your area 2. And this one is now the summation. So we now have your, so this is A1, this is your A2, and this is now the summation. And then we now have the area in square inches. Area 1 is 280 square inches, and area 2 is 50.266. 50.266 square inches. So let's try to get now your x. So we have your x. For area 1, it is 7 inches. For area 2, it is 6 inches. Let's try to get now the value of y. So this is now your y. For the first area, it is 10 inches, and the second area, it is 12 inches. Now, let us try to get now your ax. So we now have your ax. So this is 280 by 7, and this is equal to 1960. 50.266 by 6. Okay, so this area in here is negative, so we have a negative area. So minus 50.266, multiply this one by 6, that is minus 301.596. And let us try to determine now your AY. So we now have your AY. Okay, 280 by 10 is 2800. 2800. And then negative 50.266 by 12 is minus 603.192. So let's try to get now the summation of area. 280 minus 50.266. So we have 229.734. 229.734. And then summation AX. So this is equal to 1658. 1658.404. And 2800 minus 603.192. So we have 2196.808. So let us try to determine now the centroid of this area. So we now have your bar x is now equal to summation AX all over the total area. And this is equal to 1658.404 all over the total area, 229.734. So this is equal to 7.219. 7.219 219 inches. And your bar y is now equal to summation AY all over the total area. So this is summation AY 2196.808. Divide this one by the total area 229.734, and this is equal to 9.562. So we have 9.562 inches. So it's equal to 9.562 inches. Hence, the centroid of this area is now located 9.562 and 7.219 inches. So this is around 7 points. So this is around at this point. So that is therefore the centroid of the given area. So this is your bar X. So that is now your bar X. And this one in here is now your bar Y. So this is the centroid of the given figure. Next, let's try to locate the centroid of the area shaded as shown. So we have a composite area. I will going to divide this one into spatial geometric figures. Okay, so I'm going to consider this triangle in here as area 1. So this is your area 1. And this is now your area 2. And this one in here is now your area 3. So we have area 1, this is area 2, and this is now your area 3. So I'm going to start. We are required to determine the centroid with respect to the given x and y axis. So let's try to consider the first area. So this is now the x-axis, y-axis, and this one in here is now the x-axis. So we have your triangular area, which is equal to, so the triangular area, so this is equal to, this is your triangular area. This now your triangular area, such that the base is equal to 3 inches and the radius of this quarter of a circle is 3 inches. Hence, this one in here is also equal to 3 inches. This is your x-axis, and this one in here is the y-axis. Now, the centroid of this one is, let's consider that this one in here is now the centroid. So, the centroid of a triangular area, is given in the table uploaded. So, that is table of common geometric shapes or geometric figures. Now, this is therefore your x of 1. So this is the first area, and I'm going to consider this is now your x of 1. Now, this distance in here is equal to, so this is equal to 3 inches also. So this distance up to this distance is equal to 3 inches. So this is equal to 3 inches. So we have the centroid, and this is equal. This is now the centroid. And this one in here is now your y1. This is your y1. So let's try to get your area 1. So your area 1 is now equal to the area of a triangle, 1/2 BH, that is 3, multiply this one by 3, or this is equal to 4.5 square inches. And then we now have your x sub 1. So it is 1/3 from this point, so that is 2/3. So we have 2/3 of 3, or this is equal to 2 inches. And we now have your y1 is now equal to, so we are getting the centroid from the indicated x and y axis. So this is the indicated x axis, so that is 3 plus. So we now have 3 plus the area, the centroid of a triangle from the base is 1/3 of the height. So we have 3 plus 1/3 of the height, which is equal to 3, or that one is equal to 4 inches. Let's proceed to the second area. So the second area, this is now this is the y-axis. And we now have the x-axis. So let's try to have now the x-axis. We have your x, and this is now your y. So the second area is this one in here. So this is the second area. Okay, so we now have your area 2, or the second area. Now, let's try to consider this one in here. So this is quarter of a circle, the radius of which is equal to 3 inches. So this is the radius is equal to 3 inches. Now, such that this is now your 4 inches, and this one is also equal to 3 inches. Now, so this area, the distance from this point up to the y-axis is equal to 3 inches. And the distance of the base of this area from the x-axis is also equal. So that one is also equal to 3 inches. This one is also equal to 3 inches. Now, in this area, I will now going to get the whole area of this, which is a rectangular area. So if I will now going to consider the whole area, so this is now your y, and this is now the x-axis. So this is your x, and this is now your y. I will going to consider the whole area. So this is the whole area. So we have a rectangular area. Okay, so this is now the rectangular area. So that is 4 plus 3, so we have 7 inches, and we now have your 3 inches. So the rectangular area, we will going to subtract this quarter of a circle to get the net area. So I'm going to consider this one as area to 1 because we divide that one into 2. So your area to 1 is now equal to, so we have area to 1 is now equal to 7 multiply this one by 3, or this is equal to 21 square inches. Again, let us try to get now the centroid of this spatial or common geometric figure or rectangular figure. So this is acting at this point. Now, so that this one in here is now your x of 1. This is now your x of 1. And this is therefore your y sub 2, 1. So this is your y sub 2, 1. So y 2, 1. So this is x 2, 1. So let us try to determine now this x 2, 1. Since the distance from the y-axis of that figure is equal to 3, so this one in here is now, so this distance up to that distance is equal to 3. So that your x of 1, x2 1 is now equal to 3 plus this one, which is 7 all over 2. And this is equal to 6.5 inches. So let us try to determine now your y to 1. So the distance from this point, from the x-axis to the base of this rectangular area is also equal to 3 inches. So that your y to 1 is now equal to 3 plus 1/2 of 3. So that is 3 plus 1/2 of 3, or this is equal to 4.5 inches. For quarter of a circle alone, the centroid is at this point. So you try to go back again the table that was uploaded before regarding the centroid of the area of a quarter circle. So let us try to remove this area so that we can get the net area of area 2. So I'm going to consider this one as area 2, 2. Now, this is now your x2 sub 2. We now have your x2 sub 2. From the y-axis, that is your x2, 2. And from the y-axis, this is now your xy2. So we have x2, 2, y2, 2. So this is now your y2, 2. Now, if you try to recall, let's try to get now the for quarter of a circle. So if this is now your quarter of a circle, you try to look at now the uploaded area. So we have the quarter of a circle. So this one is now the quarter of a circle having a radius equal to r. So we have area of a quarter of a circle. Now this centroid is referred from this axis and from that axis. Now, such that this is therefore the centroid. So we now have this one as now your okay. So this is now, I'm going to consider this is your x, and this one in here is now your y. Now, so that this distance in here shown in the table uploaded is bar x. So that is your bar x, and this distance is now your bar y. So that is now your bar y. So if this rectangle, if this quarter of a circle is considered alone, then your bar x in there is equal to 4r over 3 pi. So your bar x is equal to 4r all over 3 pi. So that your bar x in here is now equal to 4. The radius is equal to 3 all over 3 pi. And this is equal to 1.273. 1.273, that is in inches. And your bar y is still equal to, so your bar y is still equal to 4r all over 3 pi. Hence, bar y is still equal to 1.273. Let's try to determine now your area 2, 2. So that your area 2, 2 is now equal to the area of a quarter of a circle. Area of a circle is pi r squared. So let's try to divide this by 4, or that one is equal to pi. The radius is 3 squared all over 4. So the area is equal to, 7.069. So this is 7.069. This is inches squared. Again, we remove the area, hence this is negative. So we now have your x22. So your x22 is now equal to, you try to take note in here now, that this is now your bar x. And this distance in here is now your bar y. And therefore, your x22 is now equal to 10 minus bar x in there. 10 minus bar x is equal to 1.273, and this is equal to 8.727. 8.727 inches. And your y22 is now equal to, so this is 6 minus bar y. That is 6 minus 1.273, or this is equal to 4.727 inches. Let us now proceed to the last area. So we now have the last area, and that is now your area 3. So we now have your x and y axis. So this is the x-axis, and this one is the y-axis. So this is now your area 3. Okay, so that this is equal to 10 inches, and this distance is now from the x-axis is equal to 3 inches. So this is now your 3 inches. Now this centroid of which is located at b over 2 from the y-axis and h over 2 from the x-axis. So this is therefore the centroid of this rectangular figure. Now such that this is now your x sub 3. So we have your x sub 3, and this is now your y sub 3. Let's try to determine now the area of this third figure. So the area 3 is now equal to 10 multiply this one by 3, or that is equal to 30 square inches. 30 square inches. And your x of 3 is equal to 1/2 of 10, that is 5 inches. And your y sub 3 is 1/2 of 3 inches, or that one is equal to 1.5. Let's now tabulate the result. For area 1, so we have 4.5 square inches. For area 2-1, so that is 21 square inches. For area 2-2, area 2-2 is the area removed from area 2, so that is negative 7.069. And your area 3 is equal to 30. Let's try to determine now your x. So x for area 1 is 2. For area 2-1, it is 6.5. For area 2-2, it is 8.727. 8.727. And for area 3, it is equal to 5. Let's try to get the value of y. So for y, your area 1 is 4, area 2 is 4.5, area 3 is 4.727, and area 3 is 1.5. So let's try to get now your ax. So 4.5 by 2, so that is equal to 9. Area times x. Then area times y, okay? Area times x muna. 21 by 6.5, we have 136.5. Minus 7.069 by 8.727 is negative. We have 61.691. And 30 by 5 is 150. Now, we now have your a times y. 4.5 by 4, so that is equal to 18. 21 by 4.5, so that is 94.5. Minus 7.069 by 4.727, minus 33.5. 415. 30 by 1.5, so this is equal to 45. So let's try to get now the summation of area. And the summation of area is equal to 48.431. Summation AX is equal to 233.809. And summation AY is 124.085. Now, your bar X is now equal to summation AX all over the total area. So summation AX is 233.809 all over the total area, 48.431. And this is equal to 4.828. 4.828 inches. And we have your bar Y is equal to summation AY all over the total area. This is equal to 124.085. Divide this one by 48.431, and that is equal to 2.562. 562 inches. So this is the location of the centroid of the given composite figure.